yesterday we had a talk on entrepreneurship and careers in entrepreneurship and innovation. And I would consider this as a continuation of the same topic, because I think it is important to understand as an innovator or an entrepreneur how product development happens and what are the phases inside of that product development. And to briefly introduce myself, currently I am the director of Enlinetics, which is a training and consulting firm based in Bangalore. Before this, I was into teaching for about 15 to 20 years. And, my 2 decades of this experience has helped me in participating in several entrepreneurial ventures and also to observe keenly some of the product development phases. So how this lecture will go is like this. I will directly delve into the subject matter in the next slide, where I will explain the 8 phases in the product development process. Then I will give you some examples of new products that have changed the world. In fact, I have some exciting examples which we can take up, which is related to product development, and then see how the product development process goes out. Then I have 2 examples which I will discuss so that we understand the phases very in detail and in a manner that will allow us to practically apply the phases into if we want to apply them to develop new products ourselves. A lot of times people think that new product development is very complicated and it is only for a few people and so on. But through the course of this lecture, I can demonstrate that it is not that difficult to create a new product if we have the right set of skills and if we develop those skills over a period of time. So anybody can develop a new product, or anybody can modify an existing product to be quite an innovative one. However, it is just a matter of how we develop the required skills in the process that we go through. So let me, without much ado, dive directly into the topic. And once I finish the topic, there will be a Q&A session so that we can understand. You can ask me any questions. There are 2 ways. Either you can unmute yourself and speak, or you can perhaps put your question in the chat box. Either of that will be all right with me. So I will look into the chat box and answer some of the questions and so on and so forth, right? So let me, without much ado, begin the topic for today and see where we go with this particular topic. There are 8 phases in the product development process. Some books might say it is 7 steps, some might say it is 9 steps or 10 steps, but more or less, I think these 8 phases are going to give us an idea of how a new product can be developed or developed and put into the marketplace. There are 8 phases. The phases are listed here. First, we discover a consumption problem. I have highlighted the word consumption problem because that is what will require a solution. So anybody facing a problem in the consumption of something or the other is what we are looking at as a commercializable venture. I have a lot of people who come to me with cutting edge technology research, and they would come up, and I would always ask them, like, what is the problem that you are trying to solve? And most of them say we wouldn't be in a position to answer this question. I'm also stressing this consumption problem because of another reason. Research has said that out of the startups that begin, functional startups that that actually see the life of beginning, 87% close down in the 3rd year because they don't have a market. Now, this is very surprising statistic to me, because I have always believed that entrepreneurs solve problems and that change the world. And if you are gung-ho upon solving a problem that can change the world, then how come it doesn't have a market? Now, there are 2 things. Development of technology is one thing, and the usage of that technology by common people is another. Today, there is a lot of research that is going on for a vaccine in for COVID-19. This is a pressing consumption problem, because I think it is very important that we discover that vaccine. And once that vaccine is out there in the market, there is a huge demand for the same, and there is a lot of wealth that can be created around that particular solution. While at the same time, there is also a lot of research going on to find out if the number pi has finite values. It's a complex problem, no doubt, but as a common man, you and me do not find the solution for such problem something that that we need to be bothered about or worried about. So there is a problem there. Definitely, it's a complex mathematical problem, and it deserves our attention because of our intellectual capabilities. But that is specifically not a consumption problem. It doesn't lead to a solution which solves directly a problem that is related to consumption of certain goods or services in the market. And that is why 84% of the startup companies that come out with their new products fail, because they fail to address a consumption problem adequately. The second phase is ideating a solution. The key word here that I wanted to highlight is ideating. Ideating means generating ideas which are a solution to the problem. Multiple solutions may be possible. We must choose the right kind of a solution which will help to solve the problem, at the same time be commercially viable. Then we do a lot of researching. Researching involves researching about the product, researching whether it is possible, and more importantly, researching whether the solution that you have arrived at is thought of to be a viable, practical solution by the market. That means we have to discuss this solution with customers, or with the people who are around us, with sometimes well-wishers, and so on and so forth. So these initial researchers, which constitute a lot of discussions, and documentation of these discussions is very, very critical for our for the creation of the solution into a commercial one. Then we do the design part of it, or it is also sometimes referred to as planning. I prefer to use the word design. And I think we had already a session with design thinking in this lecture series, which I noticed in the brochure that was shared to me. And I think that design is a very, very important part of it. So once we look at the design and we design the solution and bring it into a physically viable format, then we look at prototyping. Prototyping is development of a functional model of your idea. Here, until this particular time, the idea is still on paper. It is not real. It is not something that is workable. It is not a working model. So prototype is a working model of your solution. And then you arrive at costing. Now in costing, you look at inventory of parts. You look at how much each part is going to cost and how much the prototype would cost in one place. And you'll also look at how, if I acquire the parts in a mass scale, how much it would cost me for manufacturing. I will come to that slightly later. And then we source this, and we may or may not be in a position to manufacture this ourselves. So we will find a manufacturer who can manufacture this one, and we will make sure that this manufacturer is not going to steal our innovation and manufacture on his own. So we enter into some legal agreements with them, and finally we launch the product. Once this is done, create an enterprise, and so on and so forth. This is pretty straightforward looking development phases. It's not very complex to understand that these are the phases, but what is complex is the thought process behind it, and the success rate behind this particular thing. So that is something that we need to look at. If you start applying this to the excuse me, if you start applying this to the regular in your regular life, you will find that. Give me a second, please. I will have a glass of water before I start. All right, I'm back. I hope I'm audible. If I'm audible, please type yes in the chat box. All right, thank you. So these are very straightforward phases of product development, and it really doesn't take much to understand this straightforward process. But what is not so straightforward is the availability of a solution. The first two phases itself are the most tough phases in the entire process of the product development. And the failure rate is very high in all of these two, in both of these solutions. And it's important that we we understand these two things much clearer. And at the end of the day, if we have to have a very commercially successful product, I think 6, 7, and 8 are also quite important. And most innovators who are probably engineers or scientists or people who have tried and doing things themselves and so on, they may not be very good in doing 6, 7, and 8 altogether. And that is where the necessity of a management expertise comes in, because management graduates and management professionals could probably help in this particular direction. And these are the 8 steps which every incubation center in the world uses as their basic model, so that new products come out of their incubation centers and so on. So if you are thinking of a new product development, then probably you should associate yourself with a good incubation center, which will help you in the first 2 and the last 3 phases, which are really very important parts of this entire product development process. So let me go and talk about the examples of this one. Yesterday, we were also talking of Sony Corporation, and I would like to give another example of Sony today. And its CEO is Akio Morita. Akio Morita is one of the founding members of Sony Corporation. And and once Sony started manufacturing electronic equipment and gadgets, Akio Morita's responsibility was to travel across the globe and take this products and services to different parts of the globe and see how they could be sold. So Sony was manufacturing calculators and other electronic gadgets at that time, and Akio Morita would take these products to USA, to Europe, and travel across and have business meetings with people and try to develop this entire product line, get business for Sony. And he was quite successful in doing this because though he was a Japanese person brought up in a very traditional way, he could quickly adapt to the changing circumstances and establish communication with a lot of people, and then move forward in this particular direction. It's very important that we notice this characteristic of Akio Morita, because unless you have the opportunity to observe things that happen in the world, identifying a consumption problem becomes a very critical aspect. So while he was traveling, Akio Morita noticed that people across the globe had a very great passion for music, right? And he also noticed that people in Japan used to carry these radios around them. They were interested in listening to news, and these radios were slightly bulky in size, and also they made some noise. And sometimes in Japan, people used to fight with each other saying, this is too loud, and turn it down. And these social clashes were quite common. The people wanted to listen to the news, but at that time, the radios being bulky and also it being having speakers which disturbed others didn't make up for a nice social interaction. The same thing he observed in America, that people carried their stereo boxes of music to the beach, and they used to play and dance. And not only were these music players bulky, at the same time they were also causing a lot of noise. So some people wanted that noise, some people didn't want that noise, and so on. And in European countries, he observed that these stereophone recorders, and smaller ones and larger ones, and depending on the size, were carried in metro stations and in metros and travels and so on and so forth. And Akio Morita came across this consumption problem, that people want to listen to news, they want to listen to radio stations, and they want to listen to music when they are traveling, or when they are on a beach, or when they have the mood to listen to. And they don't have a personalized solution which could give them the ability to which can be easily carried around, and at the same time which also had the capability to be personal and not disturb others. So Sony, after Akio Morita observed this, he came back and talked to his research team, which was developing products at that time, and said, I want 2 things. One, I want a small device that can play music, and a small radio. And the second important thing is it should be in a position to play the music in a most personal way. And after months of research, Japanese people were very good in miniaturization. That means making things smaller. So these technology grads that were working with the Sony Corporation were well aware of the miniaturization process. So they developed what we today know as Walkman. And Walkman was a Sony's product. It's a brand that Sony developed for a personal stereophone recorder. And Walkman became so popular that we call every personal stereophone recorder with a headset as Walkman today. So there are multiple companies that were manufacturing Walkman still of late till we got the MP3 format. I'm going to talk about that in a short while. So this was a runaway success for Sony. So Sony, what they did was they developed a prototype, tested it, and it worked out very well. And they saw the stability of the device and so on and so forth. And it could be battery operated, and it was very light to carry around, and it had the 3.5 mm jack for that was invented at that time. And so they had this jack, and which you could put in your ears and listen to the music without causing disturbance to others. And they patented this product, and for about 20 years, nobody could manufacture. And Sony had a very good success with the Walkman around the world. And this is something that came out because Akio Morita noticed and observed a consumption problem, converted that problem, ideated it, developed into a solution, and offered it to the world. This changed the way music was in the world, because then the consumption of the Walkman became quite a quite a normal thing, and people started listening to music. Then you could record music also, and there are so many things that came through aside from just listening to music. This is one innovation that changed the way the world was working. Music became really, really personal. People started, like, in a household, you had 4 or 5 Walkmans with each person having their own collection of cassettes, and it made music personal. It made sure that I could explore my taste of music without interfering with somebody else's. And that's how the consumption of music itself changed because of this particular gadget. The second innovator that I would like to talk about today is Karl-Heinz Brandenburg, who invented MP3. Now, these were the days, once again, where internet was growing, and as we know, the internet lines of transmission are made of telephone lines, and they couldn't carry. Today we have fiber optic cables, wireless transmission, but those days it was not the case. And to transmit a large files over the internet was a huge problem. And since the advent of personalized music and so on, internet also started having music files, but the problem was the size of the audio file was very, very large. If you remember, I think some of us who are in my generation would remember that one CD would cost us was quite expensive, but it could store only 10 songs. So the audio file format was either WAV format or another legacy format, which the person who was creating the music had, so that people don't steal it away and so on. So these file sizes were very good. Digital music was really, really awesome. And a lot of people were creating music with MIDI devices, musical interface digital interface devices, musical instrument digital interface devices. A lot of people started creating digital music. That means instead of creating and recording music on magnetic tapes, people started using electronic devices to connect with computers and create music. That music was really, really awesome. And a lot of people were producing CDs and so on and so forth, but the file size was very large. And if somebody wanted to share this music on internet, it would become a nightmarish affair. So Karl-Heinz Brandenburg was a PhD scholar whose job was to figure out how to compress these music audio files so that without the loss of the quality of the music, if he could reduce the size of the file. The result of his research was the MP3 format today, which is popular. I'm talking of MP3 format because of 2 reasons. The Karl-Heinz Brandenburg, the work that he did was so really, awesome that, one of the things is which type of, to reduce the size of the file, I had to choose a sample music file and experiment on that. And the way Karl-Heinz Brandenburg chose his file, choose what kind of music file he wanted to compress, and the solution, when it was used on every other type of file, it should work the same. So he would compress one single file, and the solution that came out of that, the compressing solution that came out of that, would work on any other file as effectively as it worked on this one. So that was the biggest problem. So he defined his problem. This was his doctoral thesis. So he defined his problem and he approached several universities. And I think initially one of the local universities in USA funded him. Then AT&T Bell Laboratories funded his postdoctoral work and so on. So he arrived at this, at this compression mechanism, which was universal. And this changed the way music was distributed in terms of on the internet. And one of the companies that made the best use of this compression method and also at the same time developed the streaming mechanism was Apple. They came up with iTunes mechanism and also the iPod device, which both of them used streaming and MP3 mechanism, and they became quite popular. And Apple started replacing Sony's Walkman very quickly, and Apple took over that particular market segment quite fashionably. So if you go through Karl-Heinz Brandtenburg's story, you will notice that he had applied the 8 phases very critically, and most critical was his ideating phase, where he had to really choose a particular sample file in such a way that whatever worked on that file worked on every other file as well. So that is the criticality of the ideating phase. Then you have the design, development, sourcing, etc. Today, MP3 is a fact of the world. We take it so much for granted. But unless and until Brandtenburg contributed the compression mechanism, it would be difficult for us to use MP3 as we are using it today. The third person, all of you would have heard of this name called Charles Babbage. I'm taking Charles Babbage's name for a very specific reason, which I will discuss in a short while. Now, Charles Babbage is today known as the father of computers, and we know that he used a mechanism called the difference engine. And even today, the type of algorithm that is used in the microprocessors is based on what Babbage created, and that's why we call him as the father of computers today. Charles Babbage was, very fascinated with a certain type of problem. In those days, mathematics and science, and I think it was in the 19th century again, 1800s to be more specific. In the 19th century, science was developing very faster. Physics and mathematics were being used for innovation in all ways of life, and mathematical tables were a crucial resource. Like, for example, logarithmic tables that you use to find out logs were very crucial. These tables, in Charles Babbage's time, these tables were manually written out and then sent for printing, and the errors in these tables were large. And if these errors were there, the precision of the mathematical calculations would not be that much. So Charles Babbage said that this was a problem. Like, human resource was actually being wasted because of this. Human resources were being wasted because of this, and Babbage wanted to find out a solution. So he started working on an algorithm which, when put on a machine, would be in a position to give the mathematical tables with precision, and all you have to do is rotate one spindle, and once you rotate that spindle, your mathematical tables are printed, and they can be done in an automated way. So errors can be reduced, machine can be, it's a machine. You can manufacture that machine in large numbers, and it would probably be utilized by every government office across the world which was looking for making mathematical tables. Now, this was Charles Babbage's idea. Now, Babbage designed the idea, put that into documentation, and approached several people for funding so that he could build a prototype. And I think after much convincing, he got one opportunity. Somebody gave him several thousands of dollars to manufacture this engine, but somehow Babbage could not manufacture and demonstrates this engine's viability. So during his lifetime, Babbage was known as a failed entrepreneur because he had one crazy idea and that idea didn't work out. And the reason for that is Babbage could not get the precision parts that are required for his difference engine. And since that manufacturing capability was not there, it was possible. So only when MIT in the later days, I think somewhere in the 20th century, 1900s, they took up a project to see whether Babbage's design was really the design, and can he really be justified as being called as a father of computers, when they built a prototype model by using precision part making technology. Uh, the model works, and it is still there in MIT's museum, if I'm not wrong. And the model worked perfectly, just as Babbage had described. So that proved once and for all that Charles Babbage was a genius who was way far ahead of his time. But the point I want to make here is, during his lifetime, he could not make his difference engine work, and he could not enjoy the fruits of his work I know during this time. So he was probably ridiculed and made fun of, and so on and so forth, and he had to suffer that humiliation during his lifetime. This is one of the risks of being ahead of your times and thinking ahead of your times. So let me just look into, I told these three examples because they are very, very relevant for understanding the phases in product development. First and foremost, things that I wanted to really help out with these examples was the first two phases, where you choose a consumption problem and where you ideate in creating the solution. The rest of it is probably more mundane in nature and doesn't require too much of creative skill. But I think the first two things is where creative genius will come into force, and that's how you start creating new products and services. With these examples, you might be under the impression that this is only for genius people like Charles Babbage and so on. But in the next stage, what I'm going to demonstrate is there are problems which are consumption problems, which are really not seen by people as consumption problems. But if once they are seen as consumption problems, there is a whole market available for you to explore, create wealth, and be innovative in your ideas. So let me delve into these examples. I have a couple of examples to share with you. So let me go phase by phase and apply the 8 phases to these two things and look at it. So let us, one of the things that you require when you are discovering a consumption problem is your observation skill. What are you looking at? What are you observing? What are you reading? What are you thinking about? That matters a lot. If you want to innovate something, you should start seeing the world around you. Let me tell you experience from my own example. Like, I entered into teaching at the age of 25, and I used to teach a subject called consumer behavior. And I really did not have the kind of marketing exposure that is required for this particular subject. So I had to really learn a lot of aspects of this subject. So what I used to do is I used to go and stand in bus stops, and at that time Food World was one of the nearest malls to my location. So I used to go to Food World and hang around the billing counter to see how people pay, what kind of interactions happen. I used to hang around shelves of food, so I used to observe what people choose, how they choose. Maybe I talked to some of the people, introducing myself as a researcher, and asked them a few questions, and I did that exercise, and that observation helped me a lot to identify the complexities in the subject matter and to talk about relevant things to my students, which gave me authority as a teacher. Without such observation skill, I wouldn't have succeeded as a teacher. So if you want to understand some things, if you want to see certain things, you must be observant. You must go and observe how transactions happen. You must sit in a petrol bunk perhaps and see how petrol is filled out, how people come and go, what could be some of the problems in that area. You must do that exercise. You must go sit in a shop and watch how people transact for change, how people get the product from whichever is the shelf, and how you can solve that problem, maybe using robotics, maybe using some other things. So basically the idea is to get into a place where you can do a lot of observation, perhaps document that observation over a period of time. I go as a guest faculty to many engineering colleges for entrepreneurship, and I suggest everywhere, like, you should choose, if you are an engineering institution, you should choose a range of about 4 to 5 kilometers in your area, and you should send your engineering graduates to go and see and observe and record problems in that particular area. It could be a traffic problem, it could be a problem of not having enough ATMs, it could be a problem of roads not being well, so that deliveries are not happening on time. Whatever be the issue, whatever. I'm not a technical guy, I'm not an engineer, so I really don't know many of the engineering problems. But if you observe things carefully, then there will be simple problems which are ignored, for which solutions are required. As an example, let me tell you, I encountered this particular product in a project exhibition by a college called B&M Institute of Technology, which is in Bangalore, and it was amazing. So one of the problems that teachers and salesmen and local commuters have is we stand for long times in buses and and in classes and while delivering our sales presentation, and we tend to develop a tendency to stand on one of our legs so that the pressure on the legs is eased out and so on. And sometimes without knowing it, one of our leg becomes a dominant leg on which we tend to stand all the time, and this leads to an imbalance in the spinal cord, which further leads to complicated problems in later life, right from things like lower back pain to clots in the blood clots in the legs and so on and so forth. So there are multiple related problems. Now, this is a very common problem. A lot of people experience this. This is an occupational hazard, I should say, because of the traveling, because of the standing that is involved in. And somebody in BNMIT noticed this particular problem and thought that this is a worthwhile thing to be solved, because if I learn to manage my legs appropriately, I don't have to suffer in my later life, because of which I may work probably better. I could be a more functional member in the society. I don't have to depend on somebody else in my later life and so on and so forth. So a lot of socially related aspects can be sorted out if teachers, salesmen, and commuters in buses and metro can have a solution for making sure that they stand in a balanced way throughout their entire career. So somebody then started putting together, now how do we find a solution for this problem? We have a model called as the Scamper model. Scamper stands for substitute, combine, adapt, modify, put to another use, eliminate, reverse, or rearrange. Substituting means taking something out and substituting it for another. Combining two different things could be a solution. Adapting an existing one, changing something in an existing, consumable is another thing. Modifying it, putting it to another use, eliminating, and so on. So this is called as a Scamper model. It's a very straightforward thing. Nothing to really, nothing is there to explain a lot about these things. So these guys came up with a solution where everybody wears shoes or footwear, and the pressure sensors are available. So if you put pressure sensors inside a shoe and adapt the shoe appropriately, then it is possible for us to give feedback. Because if pressure on one side increases, then I can send a feedback signal so that I can balance out. So that was the solution that they came up with. The third one is researching, where we discuss this. Now, this is an idea. This is what came to my mind. I need to see if this idea is valid and it is worth testing. So if I have to build a prototype, I have to spend some money on that. So before I spend that money, see, that money may be 100 rupees or 100 crores. That doesn't matter. But before I make sure that I'm attempting a solution or attempting to develop a prototype, it is important to discuss. One of the ways that, in this particular case where discussions were happened was they discussed this with classmates, asked them, explain the idea, like, listen, dude, if I put pressure sensors in a shoe, this problem will be solved. Is it a good one? Then you go to your research guide, specifically because this was a final year engineering project. So there was a research guide available. Discussion with research guide happened. I'm not very sure whether they spoke to future consumers or not, because it's an engineering project and probably there was no idea to commercialize this, but just to learn something new was the idea of the student. So I don't know if that was the case. But if you are to develop a commercial solution, then it is important for you to go and talk to people outside and discuss that. And finally, you need to plan and design for this. Now, you had a lecture on design thinking. So this particular solution, when you are adapting something, must be in a position to modify the shoe and make a shoe. There are two possible solutions. You make a shoe that has embedded pressure sensors inside, like while manufacturing the shoe, it comes with embedded pressure sensors. It comes with embedded pressure sensors, and the critical factors is the placement of the sensors, the feedback mechanism, how will you give feedback, and fitment into an existing shoe. Now, why I'm saying it should fit into an existing shoe is because you can't expect everybody to, buy a new pressure sensor, enabled shoe by discarding already. So people buy expensive shoes, like say maybe a Nike or maybe some other sport shoe or some other fancy shoe, and they don't want to discard that. So if you if you have a solution that fits into an existing shoe, it becomes easy. So these guys, what they did was they took a small plastic material which was light enough. They cut it in the shape of a shoe of a particular size, and they put pressure sensors and the circuitry required for haptic feedback. That is, the vibration that happens is called haptic feedback. So they put that into the entire thing, tested it out, and put it into a shoe, and that was their design part of it. So it is prototyping. Then, in this case, you can't do 3D printing, but for a lot of items, you can actually do 3D printing to see whether your model really works out or not. For example, you might develop an airplane model, and you can 3D print your aero model, put it in a wind tunnel to test it out, whether that prototype is working or not. So 3D printing is a very rapid prototyping solution which we can think of. So prototyping is nothing but developing a working model, and sometimes 3D printing is a great solution for that working model. So now they made a rough model of this, and when I was in the exhibition as a judge, I tried this shoe, and this had haptic feedback. Like, whenever I put my pressure on one of the legs, it used to buzz and vibrate, and therefore I could make a balanced stand. One of the things that the student told me at that time was, if I wear this shoe for 21 days, I automatically learn how to balance myself. I don't need this shoe after 21 days. Then I asked him, what will you do after that? Then he said, donate it to somebody else. And that way you are saving money. That way you are really helping a lot of people, and you are also helping your colleague and so on. So if a college buys about 100 of these models or 50 of these models, then all the teachers in the college are automatically balanced, and I think that works out. Though commercially it looks like a very not a good thing to do, but this guy was of an ethical mindset and said, if this can be the solution for all teachers, and it would work out very well, so the world would be definitely a better place. And now I thought at that time that if this really becomes a commercial model, he will put a lot of doctors out of business, right? That's on a lighter note. So prototyping is making a rough model. So I tried this shoe in a project exhibition. It had haptic feedback, and it worked really well. Then you do the costing of this, like how much it would cost to manufacture. So what you do in costing is you take an inventory of parts. You take that, like there is plastic involved, there is cutting involved in this one, there is pressure sensors, then there is the feedback technology. So there is an entire circuitry inside, how much each part would cost. So you write down in a spreadsheet what are the different parts and what is the cost of each part. When you are making a prototype, you are making 1 or 2 models, so you would buy very less number of parts. So therefore, when you are commercializing this, you would look at economies of scale. That means if I order these parts in large numbers, what is the kind of cost reduction I would get, and determine how much scale of manufacturing is required to reduce this cost to a fraction of what it costed you to develop the prototype. And you will also look at turnaround time, in the sense that how much of inventory you need to have so that you can make X number of products available in the marketplace, and how much time do your suppliers take to supply these parts to you. Is it can it be done on a daily basis? Is it on a weekly basis? So that you don't run short of your raw material. So you calculate the turnaround time for when you are doing the costing as well. Once the costing is done, you source, and this particular product was stopped there as a project exhibit. I have not followed with them, so I don't know whether they really made it into a commercial solution and whether it is successful. But if you, having done the costing, then you source the product, you find a manufacturer for this particular product. Now, one of the most important things you should remember when you are finding a manufacturer is that you must protect your intellectual property. Now, this entire thing that you created, that these guys created as as a product, is their intellectual property. They found out a problem, they worked on a solution, and it is quite fair that they should reap the benefits of their intellectual work. So you apply for a patent, and then you sign non-disclosure agreements with the manufacturer, and you also sign competition related documents, like you can't make the same product for another competitor for the next 5 years, 6 years, depending on what you do. So that's one thing that you need to do. Then you approach industry associations and directories. You scan those directories for finding a person who can manufacture this product at scale. And since you know the costing, since you know the vendors who are supplying this particular, you have done that homework. All you have to do is give them that numbers and ask them to partner with you to manufacture that. And finally, out of several people whom you have spoken to, you look for, you ask for a proposal from each one of them to associate so that you can take a look at the capabilities that are available with the manufacturer and give them the job of manufacturing this at scale. Once you source this, once you do this background work, it is time to launch the event. It is time to launch the product. You would make the world know that a solution has been found out. You create a launch event, you do a public relations campaign, and maybe you start an enterprise which will hold the entire thing together, like Edison did, or like Sony already had an enterprise. So through that they offered, and so on and so forth. So these are the 8 different steps that are involved in this product. Let me go through one more, quickly, one more example in the next 2 minutes, which is really, really simple and has quite a good market potential. So one of the consumption problems was heavy users of smartphones. They hold the phones for a very long time in their hands and they have painful palms and so on and so forth. So imagine you are traveling for work and you want to read a book on your smartphone, or you are playing a YouTube video, or you are enjoying your Netflix subscription because it's your personal time. There is nothing much better to do than going to sleep. Maybe you want to watch an educational video or whatever it is. So in that case, you have the phone on your hand for a very long time, and holding it for a long time causes pain in the palm. So what is the solution for this? Somebody came up with this solution. So this is a combined solution where you combine a ring with an adhesive plate and put them together. It forms a simple solution, and it is quite an effective solution as I see it, because these are quite common things that are available everywhere. So what are the planning and designing aspects? So first thing is it has to stick to a surface, and different mobile phones have different surfaces, and we also have the mobile phone covers that people use. So different covers have different surfaces. So the adhesive that you put there should be strong enough and should be versatile enough to stick to any different surface. So you need to do the research on that, find out what it is. Then the form factor, that is whether it should be a square plate, a round plate. There are many other solutions apart from this ring for the same purpose, but I find this to be the most, so what is the shape of the plate? Could it be square or round, and so on and so forth? You define and you decide what on that. Then you test out that, saying if it has a square shape, what will be when you apply pressure on this one, will it come out easily compared to that of when it is in a round shape? So the form factor has to be researched. A lot of design thinking has to go in. And then some simple things like what should be the diameter of this ring? What should be the surface area of the plate, and so on and so forth. These are technical engineering related aspects. And once you research all of them, it is possible for you to prototype that. Now, once you do this, then here a lot of consumers were spoken to before coming up with this, like, how they use mobile phones, how long they look into that, and so on, how long they hold their mobile phones, how long they travel, etc. So a lot of talking to consumers would have been done. And this is a very typical candidate for 3D printing. Once your design is ready, I think you can actually get it 3D printed in a, wherever you would, wherever there is a 3D printer available. So once you 3D print this, then it is possible for you to experiment it and so on and so forth, show it to people, try and test it out, the various engineering parameters that you have worked out as a theoretical solution, and find that whether this is working model or not. And costing wise, today this is available between 20 rupees to 100 rupees in different sizes, shapes, and so on and so forth. So I think there must be at least about 10 to 15% margin on each one of these things. So there is a possibility that, this is costing that much less. So look at an inventory of parts, look at how, if you look at the vendors of these solutions and talk to them about wholesale prices. And once you get the material, you can actually find out the cost of this one. And one of the questions that I have for sourcing is, can we 3D print this? So now if I can 3D print this, my manufacturing becomes much simpler and easier. I can set up one room in my home to 3D print that whole solution, and I'm done with it. So it becomes a cottage industry kind of a thing, where at home we can manufacture this and send it out, or I can ask homemakers and I can ask them to invest in a 3D printer, or I myself can source them a 3D printer, give them on rent, and business model can evolve around this. So can that be a good sourcing solution is my question. I don't know how these products are really manufactured right now, So I'm just putting a question for you to think about and work on that. Then I think that's the end of my presentation. I don't want to get into the launching and so on, because it's an already launched product which is available. My objective in talking to you about this is these two products is that if you are observant of consumption problems, and if you can think creatively over a period of time, it is possible to innovate, and it is possible to work on solutions which are not available. I might want to end this lecture with a simple anecdote. Once in space research, a lot of people, you can't use pens in space research, right? Like you can't really be carrying a pen because there is no gravity, and the ink will not fill and so on, and but you have to still write, right? Americans spent, it is, the story goes that the Americans spent billions of dollars in research where Russians used a pencil. Now, I mean, there are a lot of controversies around this particular anecdote, but that apart, I think if we are capable of creative thinking, it is possible to solve consumption problems in very simple ways and find solutions for a lot of things that matter to us. So that is something that I wanted to leave with as a message in this particular lecture. So I'm done with. Thank you for giving me this opportunity, and I'm open to question and answers now if there are any.
Participants, if you have any queries, please ask to Rajesh.
Thank you, Soumya Prasad. You're most welcome. You said thank you. It's a nice presentation and informative session. Thank you very much for the compliment, man.
So, any queries, you can ask your speaker. So, definitely the speaker will clear your queries.
So if they don't have any queries, I have a query, sir. How did you like this presentation? Was it,
Sir,
motivating enough for you to?
definitely, sir. Definitely, sir. Presentation went on well, sir. You have given a very good information regarding the product phases, the different stages. I think one question from Soumya Prasad.
Yeah, right. I will read that. So Soumya asked me, can you please share your PPT? Yeah, I think I got that. So I can share the PPT with Vinay sir, and probably he can
Definitely,
distribute it across to all.
definitely.
Sir, my request to you later to this presentation, please share your email ID so that I can send it across to you.
Sure, sir. Definitely. Right now, I'll thank you. Sure.
Yes, sir. Thank you. Thank you.
Sir, your presentation is excellent, sir, and you have given the very good information on the stages of product phases, 3D printing, and all those things, sir. Very informative session, sir. And
Thank you.
Thank you for accepting our invitation, sir.
Welcome.
I think, anyhow, sir, on behalf of the Seshadripuram Institute of Management Studies, I would like to thank you, sir, because of your being a guest speaker for today's session,
Welcome, sir.
for taking the opportunity because of your precious time and consenting to be the guest speaker. And sir, indeed your words have inspired the participants. I extend my sincere thanks to the director, Seshadripuram Institute of Management Studies, and our teaching members. last but not least, I thank all the participants for showing their interest of today's session. Once again, I will thank you for your.
Welcome, sir. It is indeed a pleasure to be associated with these lecture series, and
Sure, sir.
I
Thank
really
you, sir.
appreciate your initiative.
Thank you, sir. Thank you, sir.
Welcome,
Okay,
sir.
sir. Once the session get over, I will get back to you, sir. Okay.
Yes, sir.
Okay.
No problem. No problem.
Thank you, sir. Thank you. I think, shall we end the session?
Yes, sir. Yes, sir. I have given the host control back, so we can end the session. That's
Yes.
all.
Thank you, sir. Thank you.